Okay, class. So today we will start with I think the final part of this chapter lah. So we will do first one is to determine the effect, yeah, the effect of data changes on dispersion based on the value of measure of dispersion and graphical representation. We'll see later. And next one is we compare and interpret, yeah, two or more sets of ungrouped data based on appropriate measures of dispersion and hence make conclusion. It's quite long, but you'll see it later, yeah. Okay, we want to see what's the effect, yeah. What's the effect of data changes on dispersion? When we change the data, what will happen to the dispersion of the data? Yeah. So the first one, what we will change is A. Each data is added or subtracted by a constant uniformly. We try, yeah. We add some number or we subtract some number from that data. So we see what happened to the. What happened to the what? To the dispersion of the data. To the dispersion. Kita tengok dispersion dia. Next one, B. Each data is multiplied or divided. We multiply or divide the data. And then C. What happened if the existence of outliers or extreme values in the set of data? We add some extreme data in that extreme value in that set of data. We see what happened. And D, what happened when certain values are removed or added in that set of data. So we'll see. So what are the effects on the measures? Each data by adding or subtracting. We start with A first. Yeah, we start with A first. So we start with stimulation 3. What is stimulation 3? You have to work in groups. Okay, class, for stimulation number 3, you are given 3 cards, right?
Yes.
A1, A2 and A3. So A2 you subtract. A2 you add 3 to the original data from card 1. And then card 3 you subtract 2. So what happened to the 3 measurement of dispersion? What happened to the range, the interquartile range, and also the standard deviation?
Same.
What did you discover? Come here, Azarina. Can you tell your friends? The 3 students come here. 3 of you come here. Just show your card. Can you tell your friends what happened?
SOP.
Show the card. Azar, can you just say me something?
The range, the quartile range and the standard deviation is the same.
Okay, what's the answer? What did you get?
Range 8, interquartile range 6.5, standard deviation 3.
Okay, Camelia, what did you find? What's your answer?
Range 8, interquartile range 6.5, standard deviation 3.
Okay, Brandon?
The range is 8, the interquartile range is 6.5, and the standard deviation is 3.
So, are you surprised
Yes.
to see, even though you add or subtract with any number, but the same number lah, cannot be different. It must be a uniform number. What happened?
It will be the same.
The dispersion is still the same. That means, meaning to say, range, IQR, and also the standard deviation is still the same. It does not change. Everybody got the same?
Yes.
Okay, very good. Okay, thank you. So,
Growth times.
that when you add and subtract. So this is our conclusion. No changes. No changes to the measures of dispersion when each value of set of data is added or subtracted. So you have one knowledge here. Okay. Next is B. What happened when the data is multiplied and divided. For stimulation 4, you are given cut B, right? And you want to see what happened to the dispersion measurement when you divide or multiply the value, the data. So this group has found the answers. So let us hear from them what are their discovery. Okay.
The original data shows that the range is 18, the quarter range is 15, and the standard deviation is 6.85857.
So when you divide each the value in the card B1 by 2, the range in the quartile range and standard deviation also divided by 2. So also divided by 2.
Okay. Can you tell the what's you got the answer?
So the range is 9, the quartile range is 7.5, standard deviation is 13.8.
All divided by
2.
2 from the original. Right? Did you get the same thing? Yes. Very good. Calculation is very accurate. Some of you did not get that connection because you made maybe careless mistake during the calculation. Okay, JC?
Actually, when as you can see in the original data, when you multiply the original data by 3, the range IQR and standard deviation also
Multiplied by 3.
multiplied by 3.
Oh, okay. For this one, range is 18. Your range is
So 54,
54. And then IQR here is 15. Yours is
45.
45. Okay. Did you see that? Times multiplied by 3 also. And finally, the standard deviation here is 6.85857. Yours is 20.57. Also multiplied by 3. So, what conclusion can you make? What conclusion? When you divide or multiply,
The range
By some numbers,
the quarter range and standard deviation will also be multiplied or divided by the same number.
by that same number. Okay, very good. Thank you very much. The three gentlemen. Oh, tall and handsome. Okay, this is the conclusion. Times 3 or times k lah, formula. If you use this formula, times k and new variance also. This one k square lah, because variance and value is you have to ada square. Yeah. So the same thing when you divide. The same thing when you divide. Your new range will also be divided by that number. And your new IQR also divided by that number. So as your standard deviation and also variance. So knowledge number 2, information number 2, you got this. It will change if you multiply or divide. It does not change when you add or subtract. A very good lesson for you. Okay. Next. What happened to the dispersion when you add an outlier? Here. Outlier is added or removed. Can you guess? Give me a wild guess. What happens to the range, IQR, everything? Huh? What's the range? What happened? Of course, the range will change dramatically. Dramatically ya, that means bukan alang-alang bukan kaleng-kaleng. Ya berubah. It will change dramatically ya, because range really depend on the biggest or smallest value. Biggest, smallest value is the outlier. It's the extreme value. It will change dramatically. What about the IQR? Will IQR be affected? Ever? when you put an outlier or you when you add or remove the outlier. Yes, Amber, yes. Kylie? What do you think happened to the IQR? Interquartile range. It will dramatically change also? Not sure. Dorina?
No.
No. Alda? It will change but not that big. Okay. The interquartile range is less affected. Yeah. It's less affected. It will change but less affected, even though it's at the end. Because if your data is very small, very few, so it will be included in your third quartile or first quartile. So it will be less affected. You get it?
Yes.
Less affected, yeah? What about the variance standard deviation? Of course it will change also. Because extreme data, outliers, you put a big data inside or small data or you remove, of course all your dispersion will change. Yeah. So as variance, variance also will increase significantly. It will increase significantly when outlier is added. Added. It will increase. And then, if the difference between the new value, between the new value and the mean, you have to check, the new value and the mean is small, the difference is small, the new standard deviation also will be smaller. Yeah, when you put that number, and that number is the difference between the mean that you have calculated is small, your ST also will be smaller. And vice versa. Vice versa, you know what's the meaning? Dan sebaliknya. Okay. The difference, and if the difference between the value that is removed and the mean, the difference between the mean and the one that you remove is small, the standard deviation will be larger. Will be larger. So this is your discovery for today.